Hi everyone, and welcome to Topic 9, Lesson 1. Today we are starting in our launch and we are looking at this problem. It says your friend begins building a figure out of shapes. He traces a trapezoid, slides it, traces one side, and then strangely stops. Complete the tracing of the trapezoid to show your friend's new trapezoid or the slide of his new trapezoid. Explain why your tracing is correct or shows the slide. So we're going to go ahead and we are going to look at the first trapezoid here and then pretend that we slid it over. And then where would we draw our next trapezoid? I'm going to grab this and put it in our notepad. And then you can go ahead while I'm doing this and try this in your student companion book. All right, let's go ahead and try this together. So you have the first trapezoid, and the second one I'll do in green. Okay, so here's our first trapezoid. They basically, so far when he drew this first part, he just drew this line, this new line right here. And now we need to figure out how far we need to go for all the other side lengths. So this line right here is 1 unit long. So I'm going to go ahead and make this 1 unit right here. This one is 1 unit across, going across one of the boxes. So I'm going to draw one here. Oh, that's not perfect. That's okay. And this is 1, 2, 3 units long. So I'm going to go 1, 2, 3. And now if I were to have used perfectly straight lines, these two trapezoids would be exactly the same because I traced and followed the same measurements as this first one. All right, so that's what they're asking you, and explain why your tracing shows the slide. That's what we did. So what we're talking about today is what happens and what it's called when you slide shapes around on a graph. And since you are learning about a lot of types of different vocabulary terms during this chapter, I want you to go ahead and find a blank piece of paper or somewhere that you can take notes as we throughout this lesson or throughout this unit as we cover the different types of transformations. And in fact, a transformation is the first word that you need to write down. So a transformation is a change in the position, shape, or size of a figure. So it means that we have an original figure that starts somewhere on the coordinate plane. It's some sort of shape or some sort of line or a coordinate point or something like that that's already on a coordinate plane. And then it's going to change. It's either going to change positions, it's going to change shapes, or it's going to change size. And that is what a transformation is. So all of the different things we're going to talk about in topic 9 are all types of transformations. So we have this original triangle here, and now we have a new triangle that is larger and in a different position than the first triangle. Here's your next vocabulary term. A rigid motion is a transformation that changes only the position of the figure. So that means that we're going to call it a shape for now, but please know that it could be a line or a coordinate point. But that means that the shape on a graph just moves in the plane. It moves somewhere else in the coordinate plane, but it doesn't actually change size. And like you saw in the triangle, where is that triangle? The blue triangle is bigger than the black triangle, so that was not a rigid transformation because it changed size. So if you have a shape and you move it anywhere on the graph without changing its size, that's a rigid transformation. So here we have the black triangle and the blue triangle. They both are the same, even though your eyes might be playing tricks on you and thinking that one is bigger or smaller than the other. They both are the same size. They just moved locations. We started here and we moved over to the right. All right, here's your next vocabulary term. It is an image. So this is kind of where we get into some funny terminology. So you do need to know an image, and an image is the result of a transformation. So if you have, let me show you here. If you have a graph, we can use our one from our launch today. The image is the result of the movement. The image that we copied is actually called, let me type it here. They're going to tell you next in this video here, but I'll give you a little hint. It's what comes before the image, so it is a pre-image. So the pre-image is the shape that we're copying, that we're moving. So this is the pre-image. This new shape, after we slid it over, is now called the image. And a lot of times those terms are easy to mix up because they don't necessarily, it's not something we say all the time. A lot of times we say like the new image or the new picture or something. But in math, we need to distinguish which shape was the original and which one was the new. So the word we have for the original shape was pre-image, and the one we have for the new one is image. All right, and if this right here, we named it as point A, we would say that is point A, and then this in the image would be the same as point A, but we say that it's A prime. And that's how we label that this was the original, the pre-image, and this is the new one, the image. So as you're writing down the definitions here for image, that's what it means when it says use prime notation. It means that we're going to put this little asterisk right here. It's not even asterisk, it's just a tick mark that signals that this is the prime spot. This is the prime coordinate, which means it's the coordinate for our new shape. All right, let's look at our next set of definitions. Oh, here's an example. Great. So we have this original triangle ABC. This is the original. This is the pre-image. And then we have the new triangle on the graph that's called the image. And all of these little tick marks next to it mean A prime, B prime, and C prime. Notice that A, B, and C are still in the same locations on the triangle. A is still on the top, B is still on the left, C is still on the right. But we name it as A prime, B prime, and C prime to tell the difference of which one came first. This is the pre-image, this is the image. All right, here is your next vocabulary term. It is called a translation. Now, a translation is a type of transformation. So a translation is a way that shapes transform. Okay, so that's how you can think of it. I always got translation and transformation confused, but a translation is a way that a shape transforms. So it is a type of transformation. So you can see this blue triangle on the screen we already have. This is the pre-image. This is where we're starting from. And we're going to translate this triangle by sliding it somewhere else on the coordinate plane. So a translation is a slide, and you might be able to remember that by the SL in translation and the SL in slide. So translation is a slide. And it's a rigid motion. Remember, that means all of these shapes are going to stay the exact same. They're just going to move locations. So you can literally picture, and you might actually even want to do this, put like a sticky note on top of the computer and use a pencil to sketch out this exact triangle and then slide it over, and you're going to be able to see where the new triangle was going to be. So let's watch here this little illustration for us. So in this situation, we first are going to translate the triangle 5 units to the right and then 5 units down. So that means we're going to start at one of the coordinates. Let's start here at this top one. And let's count over 5 units. So we're going to go 1, 2, 3, 4, 5 lines. And then 5 units down would be 1, 2, 3, 4, 5 lines. So the black triangle moved 5 units to the right and then 5 units down in our translation. Sometimes they're going to move just to the right, sometimes they're just going to move down, sometimes they'll move to the left, sometimes they'll move one direction and then another direction. So those are all things that are okay when you're working with translations. But note that they didn't move from here to here. They didn't move on an angle. They have to move kind of like in a 90-degree pattern. They have to go here and then down. They have to move in the shape of an L. They can't just slide on an angle down to the bottom. All right, let's look at this next part here. Every point on the black triangle is important to note that it moves the same distance. So we could have started with this triangle point and saw that it would move 5 and then 5. This one moved 5 and then 5, and that's how we got this new triangle down here. All right, so I wanted to show you this little clip right here. This is just showing that the triangle, the original triangle, remember the pre-image, could have gone anywhere. It could have slid over here, could have slid again down here, it could have slid over to the left. It can really go anywhere on, actually let me back it up a little bit. Here. See, it can slide anywhere on the coordinate plane. It never changes size, it just moves around its location, and that's totally okay. That's all okay in the translation world. But we keep the original triangle on the graph so that we can see where it was originally, and then we draw the new triangle called the image so that we can see, compare it to where it used to be to where it is now. So that's why we always have the pre-image and the image on our screen or on our graph at any time. Okay, so which one of these is a transformation that is a translation? Remember the SL, it slides. Which one of these is a slide? Well, this one looks like it flipped. This one looks like it grew. And this one looks like it slid. So this one is our slide. Now, which one is showing triangle DEF and triangle D prime, E prime, F prime after a translation? Well, take a look. These ones look like they're different shaped triangles. These ones look pretty similar. Let's look at the other ones just to make sure. Oh yeah, and look, and this one is in a different position. So this one is completely flipped. So that one's not a translation. So that means we're only able to say option 2. And that's what you should write in your Got It book. We're going to do the next problem in your student companion book together. So it says the vertices, which are just the names of points, the vertices of triangle JKL are -4, 1, -2, -2, and 1, 2. If you translate JKL 4 units to the right and 2 units up, what are the coordinates of K prime, the new K? So let's go ahead and try this. So we first need to move them 4 units right and 2 units up, and we're specifically focusing on K. So we're going to start with K. 4 units to the right. Let's count. 1, 2, 3, 4 to the right. We can't stop here because it also moves 2 units up. 1, 2. What is this coordinate right here? It is 2, 0. So the coordinate is 2, 0. And we could have, we can still do this, find all of the other coordinates by moving them 4 units over, 1, 2, 3, 4, and 2 units up. So this would be J. I'll color that one pink here. And then we can do L as well, 4 units to the right and 2 units up. 1, 2, 3, 4, and 2 units up is here. So if we were to connect this blue to purple, that is not a straight line, to purple to here and back up, if those are perfectly straight lines, we would have the same size triangle with all the same measurements because we translated the triangle 4 units to the right and 2 units up. You can also use arrow notation to write a rule. So we can say if our coordinate, original coordinate, has an x plus 4 and a y minus 2, that just means we're going to move right 4 units and down 2 units. If this was x minus 4, it would have meant we moved left 4 units And if this was plus 2, it would have been up 2 units.